Kerbal Space Program, a Realism Overhaul install, and an attempt at recreation of a real-world project called ExoMars. This is a two-part project. The first part is going to be launched tomorrow, 3:30 p.m. in Baikonur, by Russian Proton rocket. The second launch is going to happen in 2018, provided everything goes according to plan with this one. I have to request, please be gentle with your commentary, because this is the first time I've ever attempted to do a video like this. Never done one before. And this particular launch may not necessarily resemble the real world, and some of the details may obviously be omitted or actually be incorrect. So what we're witnessing here is a attempt to reach low Earth orbit with our payload on top of our heavy lifter, the Proton rocket. This is now the second stage that's burned off, and we are on to the third stage. When a rocket is launched, the most efficient way to get to orbit is to burn towards the east. This basically uses Earth's rotation to reduce the amount of delta V, or speed needed that the rocket needs to attain to achieve orbit. Now with this launch I had to burn towards the north, so this is not a very efficient launch. I don't know whether in real life the launch is going to be so much north as my launch is. So if you can see on Earth here, the path is actually very much towards the North Pole. So we have now achieved a fairly circular orbit, a parking orbit, from which we will then start doing the exit burn towards Mars. Let's switch to VAB and do a review of our rocket. Let's have a look at our rocket. I have to say at this point, thank you very much for Mick. He has actually developed and designed this whole model. This is a Proton heavy launcher. It has been flying since mid-60s. Very efficient, very fairly reliable rocket. It's using 3 stages. It's powered by a hydrazine fuel, which is extremely toxic. And for that reason they're thinking of abandoning it and using something else in the future. It has 3 stages: stage 1, stage 2. Now stage 2 ignites while stage 1 is still working. The exhaust goes through this construction here, and this is to basically help with what's called ullage. So the engines will not ignite if the if there is vapor in the fuel lines, the ignition will actually resemble detonation rather than ignition. So to provide a smooth ignition, you can't have any bubbles in the fuel lines, and for that the fuel needs to be at the bottom of the tank, and for that you need to have some sort of thrust. So that's why those engines are ignited before this thrust from the first stage is gone. And similarly, the third stage works the same way. This third stage has an engine that does not turn. So for turning and for stability, it has those little engines that provide gimbaling, and they're called vernier engines. So that's the three stages of Proton. This one is basically the fourth stage. Now this stage is a legacy of the moon rocket, the N1 moon project that the Soviets have been working on, which did not succeed, obviously failed. It had 4 big failures, but this legacy is still with us. This little thing is a Kerolox engine, and has some verniers running on UDMH, so synthetic kerosene and liquid oxygen, Kerolox. It has 5 ignitions. I'm not sure how accurate it is, and I'm not sure whether in real life it has more than 5, but yeah, 5 ignitions, so it has restart capability, and this is basically a space tug. This will provide the exit thrust needed to actually send this whole thing to Mars. Let's have a look at the payload itself. So ExoMars has 2 parts, the TGO orbiter and the Schiaparelli EDM lander. The orbiter is roughly 3.2 tons in weight. The lander is about 660 kilos, could be 630 actually. This one, so the orbiter has an engine to provide the insertion burn into the Martian orbit. It has one engine of about 420 newtons of thrust. This is way too difficult to model in Kerbal Space Program, so I've just added a whole heap of thrusters, which are roughly 1 kilonewton each. So it's using a hydrogen propellant, which is long storage, does not evaporate, easily detonates on contact with the oxidizer. TGO will be staying in orbit for quite a few years. We will be providing a communications relay till at least 2022. It has a methane detector. It has a color stereo camera, which will be very interesting to have a look at once the pictures come in, provided it works. It has a neutron detector to look for, I think, hydrogen in soil of Mars, and has an atmospheric suit to look at the Martian atmosphere. Some of those instruments are provided by Russia, and some of them are European. The lander itself does not have too much in terms of a science payload. It is basically a technology tester. Once it decouples, it will enter the atmosphere, slowed down by an ablative heat shield. Then parachutes deploy to slow it down further. It will be slowed down from roughly 5,000 meters per second to 70 meters per second, and at 1 kilometer altitude, all of that stuff jettisons. and what's left is the actual lander, and the lander will slow itself down with the help of rockets. And at a few meters above ground the rockets cut off and it will free fall, and it has some collapsible structure to absorb the last bit of kinetic energy and hopefully survive. It only has batteries, it doesn't have any solar panels, it doesn't have any RTGs, which is a radioactive battery, so it only has batteries. Once those batteries run down it will die, but hopefully not before it can transmit the OK message that it has made it safely to land. It has a communications array which is provided by NASA, so NASA will use its own satellites to communicate with this lander and send the signal back to Earth. It has a little camera that will take a few pictures, I think 15 pictures or so, as it comes down, and hopefully those pictures will be transmitted back to Earth, and that's about it. Now I'm having to stabilize the fuel before ignition, so this is what I'm doing here with the verniers, and the ignition of the engine is coming up now. I should mention that by default Kerbal Space Program does not look like that. This one is using a lot of add-ons, Real Solar System add-on by Nathan Kell, Scatterer by Blackrack, and environmental visual enhancements by Ryan Bray, and there's a lot of other people that have been involved with developing a lot of add-ons for this game, which is absolutely incredible. This is a second burn of the Earth departure stage towards Mars. I had to split the burn into two parts because the thrust to weight ratio on this spaceship is quite low, so I would have too many cosine losses firing the engine at a non-optimal time, so therefore I raised my upper ups first and then did a second burn later. We have now completed the burn towards Mars. Unfortunately, I have used MacJab to provide me with a rendezvous and the burn parameters. However, I've noticed later on that this is actually not quite correct. The real ExoMars will rendezvous with Mars in 7 months, so the trip will take 7 months. My trip here is going to take 10 months, and the end result is going to be too much velocity at the destination. Another interesting occurrence is that this path will take me into the sphere of influence of the moon's gravity, so I will actually have an encounter here with the moon, and it will have some gravitational impact on my trajectory. I don't know if in real life they had to take into account the moon, but in my case here I had a close encounter with the moon, which is quite unlikely and quite interesting. I had to do an adjustment maneuver to get myself closer to Mars. My original exit burn was not quite accurate enough. I still have a tiny bit of hydrazine left in my Blok-DM stage, so I haven't ditched it yet, and I'm using the last bit of it for this maneuver. And here you can see the gravity impact of Mars on the end trajectory. This whole thing is quite fiddly. I need to get a trajectory that enters the atmosphere but doesn't dip too much into it, otherwise it will not survive. So this is coming close to Mars now, and I'm setting up my trajectory exactly how I want it. I am going to ditch the Schiaparelli lander from the orbiter, and lander will be on its way to hopefully land, while orbiter will do an insertion burn to then put itself into an orbit around Mars. The real spaceship is supposed to do this maneuver, separation maneuver, about 4 days before the rendezvous with Mars. I have done this maneuver about a day and a half out, just because it's just easier to do so in Kerbal Space Program. The lander's heat shield, unfortunately, the part in Kerbal Space Program is way too heavy, so I basically substituted the heat shield with a aerodynamic shell, and I was hoping that it was going to be able to withstand the heat, and unfortunately I was wrong. Also, the high speed did not help. Okay, that was not supposed to happen. I have now decided to try this rendezvous with Mars again, and I will attempt to use the actual orbiter as a heat shield. I will also use the orbiter's delta V and engines to try and kill as much velocity as possible before the rendezvous, and hopefully that will provide enough cushioning for the lander to land safely. Now obviously in the real world they would never ever attempt something like that. I'm only trying this because I know that the heat shield part of the lander is just not correct for real solar system installation, and I didn't really feel like modifying parts myself, so basically it's a clutch to get my lander to land. Now also the visual enhancement modes unfortunately aren't that accurate for Mars, and there are all sorts of funny looking things happening as the descent happens. This is a very long burn because the thrust to weight ratio on this ship is very low. But through magic of video editing it looks quite manageable. However, in real game time it was about 40 minutes long. Now I'm preparing for the descent through the atmosphere. Interesting as well that to see how the trajectory drops very rapidly as the speed is decreased through the friction with the atmosphere. In retrospect, I probably could have used a procedural fuel tank as a heat shield rather than a aero cone, and that possibly could have withstood a higher heat tolerance on descent. Now the parachutes are deploying. So my trace gas orbiter has done a great job at providing a heat shield for me, and now I've ditched it, and this is a true lander as it is in real life, as it should be in real life. The parachutes are supposed to slow the lander to roughly 70 meters per second. However, in game they actually slow it quite a bit more, I think to about 30 meters per second. I think there's two parachutes at 12 meter diameter each. Could be wrong on that, it could be one. So now I'm ditching the heat shield, and now the rocket engines are exposed. And in real life, once the altitude reaches roughly a kilometer, the parachute is jettisoned, and the lander starts descending on its rocket engines. The thrust to weight ratio of this craft is roughly 2, so it can slow itself down fairly quickly. The last few meters the lander is in a free fall, and some of the metal frame components are there to provide the and there we go. Successful landing. Some explosions notwithstanding. Now we can deploy our NASA provided communication system and do our little science experiments, whatever they are, and transmit the photos and camera photos. And thank you very much for staying and watching this video. Bye bye.